Okay, this section, section 5.2a, deals with simplifying integer exponents, part 2, and 5.1 was the simplifying integer exponents, part 1. Basically, the skills that you learned from the first section were that you add powers when you're multiplying like bases. You learned that you subtract powers when you are dividing with like bases. And that also worked with the negative power rule as well, how you would flip things from the bottom to the top, or the top to the bottom, and it would change the sign of the power. Okay, it would change the exponent from positive to negative, or vice versa. So we did that, and also you learned about that almost anything to the 0 power, with the exception of 0 to the 0, pretty much everything you look at on here raised to the 0 power is going to be 1. And then you would factor that into your calculation and figure out the answer. So those were the skills from the previous. In this section, what you're going to see are some problems that are a little bit more complex. And this one here actually is kind of like the previous section. But you're going to see some additional problems in here on the next examples, where you have things multiplied that are raised to powers, and then there'll be parentheses, and then they'll be raised to the power, another power on the outside. And you're going to need to know that you multiply the powers into the parentheses. So we're going to look at those examples, and we're also going to look at some examples with fractions, how when you have a fraction raised to a power, it's the same as raising the top and the bottom to that same power. So let's start with this little example here. They say 4 times parentheses m to the negative first times n. So m like Michael, n like nickel. You don't really even need these parentheses here because there's no power on the outside, and there's nothing to distribute. There's no plus or minus sign here, so really what I see is 4 times m to the negative first times n without parentheses, and then the m to the negative first goes down bottom as m to the positive first. So we'll create a fraction that says 4 n like nickel, and then down bottom m like Michael, 4n over m. And that should be the answer. Okay, now here's something like I was talking about. You have 5 on the outside, which we'll deal with second. But first we need to say, what does this third power do to this negative 6x squared on the inside? Well, what it does is it raises negative 6 to the third power and x squared to the third power. I think what I'll do is I'll go through the tutor mode, because once we get into a lot of steps, you really need to see it instead of me just talking through the whole thing. They show, based on the power rule, they say what's going to happen. You're going to end up with a third power being applied to each of the guys on the inside. So negative 6 is going to end up being raised to the third power, and x squared is going to be raised to the third power. So Hawks is trying to break it down into steps for us here. And then they're kind of like, well, what do you have on the inside now? Well, up here, if I raise negative 6 to the third power, parentheses capturing this, 3 is an odd power. I've got a negative base, so I'm expecting a negative. And then what is 6 times 6 times 6? Well, that's going to be 216. I did that in my head, but you could use a calculator, whatever. X to the second raised to the third. What do? You multiply the powers in this situation. Okay, this is different than when we added the powers, right? It's a power and then raised to a power again. That's a multiplication. So 2 times 3 is 6, so we get x to the 6th tacked onto that. Okay. say, well, what's the final answer? If I take 5 times negative 216, it's still going to be negative, and I'm going to end up with, I believe, 1080. So negative 1080 x to the 6th. And that's the final answer. Okay, so let's go to the next one. Alright, here's a fraction problem. And this is a nice example to show that you can raise the top and the bottom to the third power instead of just having the whole thing raised to the third power. Now they may actually do this slightly different. There's two ways to do this problem, so let's see what they do, and we'll try to lean on it their way. Okay, nope, they're doing just what I was saying. They're saying if you have the top a cubed b squared, then a cubed followed by b squared is going to be cubed on the top, and then ab on the bottom is going to be cubed as well. Okay, that's the answer to that step. Now what they do is they break it down into further steps, and they say, well, if that's true, then cubing the top means that I'm saying a cubed is going to be cubed, and b squared is going to be cubed. So it's basically saying, hey, I cubed the top, now that means that I'm cubing each factor. Same thing below, a is being cubed, b is being cubed. Okay, and then they want you to recognize, see, they wrote it all out on this step, saying this is what we've got. What do? It's something raised to a power again. I know that I multiply, so I've got a cubed to the third, which is a to the ninth, b squared to the third, which is b to the sixth, and then down below it's just a cubed, b cubed. The parentheses don't do anything for us there, so it's just a to the third, b to the third. Okay, submit. And then they want you to do this little step here, which basically says, hey, you have a to the ninth, b to the sixth, a to the third, b to the third. Your a's can go together and your b's can go together, because in the previous section you learned that you can subtract the smaller power from the larger power and preserve the base. So I've got 9 a's and 3 a's. I'm expecting to take the 9 power and subtract the 3 power from it. With the b's, I'm expecting to take the 6 power on top and subtract the 3 power from down below. And that's correct. So when you do the calculation, they have a lot of steps here to make sure you really get it a step at a time, which Hawks is pretty good at. Once in a while they miss some steps, but you've got a to the sixth and then b to the third. Make sure that's a power, and click submit.